Previously, we looked at scatter plots as a way to visualize the relationship between two variables. Now what we want to do is add to that by talking about the correlation coefficient, which is usually represented with a lowercase r, sometimes with a capital R, but generally a lowercase r. And it's a measure of the strength and association of the linear association between two variables. When we look at interpreting our value for r, that correlation coefficient, we'll always have a value that's located between -1 and 1, including those two values. So the smallest possible value we can get for the correlation coefficient is -1, the largest value is 1, and obviously right in between those two values would be 0. A value of +1 means that our two variables have a strong positive association. When we have a positive association, it means the two variables change in the same direction. So if our x variable is increasing, our y variable is increasing. And similarly, if our x variable is decreasing, our y variable is also decreasing. So that change happens in the same direction. If our value for r is -1 or close to -1, then we have a strong negative association. Keep in mind, positive and negative don't mean good and bad in this case. They just mean corresponding or opposite behavior. So in this case, if we have a strong negative association, it means our variables are changing in the opposite direction. So if our x variable is increasing, then our y variable is decreasing. And similarly, if our x variable is decreasing, then our y variable should be increasing. The two variables change in the opposite direction of each other. They have the opposite behavior. And then if our value is 0 for r, or close to 0, that means there's no association between our two variables. So as we get closer to -1 and 1, we have strong associations. It's just the type of association. As we get closer to 0, we have less and less association, with 0 representing absolutely no association. In example 1, we're given a linear model that's already been created and graphed along with the corresponding data. What we want to do is use this graph to answer the following questions. So in this case, we could say that the linear model is a good fit for the data because all of the points are close to that straight line pattern that's graphed along with them. Since the slope of the model is positive, then we can say that the correlation coefficient r is likely close to +1. So an increasing line, when we create that linear model that sort of represents the path our points are following, if we have a good fit and if we see a positive trend in that line, if the line is increasing as we read it from left to right, then our value for the correlation coefficient is likely close to +1. In example 2, we again see a linear model that's a good fit for the data because that line follows pretty closely to the path those dots are plotting for us. But in this case, we see that the slope of that line is negative because the line is decreasing as we read the graph from left to right. And that means our value for r is likely close to -1. Meaning we have a strong negative association. As our x variable is increasing, we see that our y variable is decreasing. We have that opposite behavior. And then in example 3, we have a case where the linear model is a poor fit for the data. So a linear model was constructed based off this data, but it doesn't really follow the pattern of the points, or I guess the better way to say it is the points don't really map out a clear pattern. They're sort of scattered around without any obvious relationship. So in this case, we would say that since the slope is close to 0, because horizontal lines have a slope of 0, and that line that we have is not exactly horizontal, but pretty close. The slope is close to 0. That tells us there is likely no relationship between these variables. And our value for r is likely close to 0. So we either see that linear model with no clear pattern to the data, or we can see that linear model following a clear decreasing path or a clear increasing path. Whether that path is increasing or decreasing tells us whether that value for r is likely close to +1 or -1, or if there's no real clear pattern, then that value for r is likely going to be close to 0.